How are you doing? Yeah. Nice. Which questions you're going to take?
Pardon?
Which one you will be planning?
We could do like, I can do one, and then you can do two. I could do three, and then you can do four, and then we can do five together. And I don't think that we will have time for six, but we'll see.
Okay.
How does that sound? Yeah. Should we start? So what's in a Minto?
Yeah.
Hi everyone. So welcome to tutorial session 2. My name is Christoph and he's Minto. We're going to be helping you solve the tutorial questions. So I'm not sure do you have a copy of the tutorial sheet? Yeah, good. There are 6 questions today. I think we will have time for about 5. And what we are going to do is we'll give you 5-10 minutes to have a go at the question, and then we will step by step show you the answer. So yeah, question number 1, you guys have 5 or 6 minutes to see what you can do, and then we'll explain you the step-by-step answer. I'm just trying to write a nice... But yeah, no, what do you think about the questions?
I think I can take 2, 3, and 4. Can you take 1, 5 and 6?
Yeah?
Okay. Because I have prepared the things.
Nice. Which one should you prepare?
I have 1, 2, 3, and 4. 5, 6
1,
is not there.
Okay, yeah, 1, 2, 3, 4. Okay, yeah. I don't think we'll have time for 6. So,
Okay.
But yeah, sounds good. And here. Timer. So what's your PhD in? Thermometers. Oh, okay. Nice. Are you in the department of Mace? Yeah. Nice. So what does thermometers mean? Or what is your title?
It's related to actually something to do with buoyancy.
Say again?
Something to do with buoyancy.
Buoyancy. Okay. Are you first year or second year?
What about you?
So my first degree is in chemical engineering, and my PhD is in nuclear engineering. And
You are completed your PhD?
No. I'm second year of research. And my topic is about sort of designing digital engineering tools for nuclear infrastructure and nuclear waste management. So it's very far from fluid mechanics. What was your first degree? Mechanical engineering. Nice. Okay. So you know a lot about fluids.
Yeah, sort of.
So do you do a simulation?
Yeah, open form.
Okay. Nice.
So it's 1, 5, and 6 coding, right? 2, 3, and 4.
Yeah. How did last week go for you? Or how did the first one? First tutorial?
First tutorial is good. I take. What about you?
Yeah, I think it went okay. It's just the students are not really asking questions.
Yeah, same.
And they're just really shy. Yeah.
Okay. So you're willing, I mean, so you want them to ask more questions?
I mean, so this is the sort of first year that I'm doing this teaching work.
Okay, me too.
Yeah, so I'm just trying to experience it. I've also have been teaching a third year module for chemical engineering, and that's
So you're doing 2 courses?
yeah, and that's very different from this. But honestly, I think I don't know. I feel like here you do more teaching than for the third year students.
Oh, okay, yeah.
Like here you're like spoon feeding them.
Yeah. These are first year students, right?
Yeah, these are first years. Yeah.
So they are new to the system.
Very new.
Yeah. They'll have a lot of expectations, you know.
Mm-hmm.
By third year they will get to know what to say.
yeah. Did you do your first degree here?
No, I'm done from India.
India.
What about you? You are from which country?
So I'm from Hungary, from Budapest, but I did my first degree here.
Okay.
So I've been here for like 5 or 6 years.
Yeah. So you are very much used to the system.
Yeah, I mean, yeah. I've done, I've been here, done this. Yeah.
I think you can start, right? Because otherwise we won't be able to.
So I said them they had 5 minutes, so I'll send it. Open. Okay. Did you guys manage to solve the problem, or are you stuck? I'm assuming that you're stuck. So this is, I think, when it comes to solving these tutorial questions and questions in fluid mechanics in general, if you have a good sort of drawing, you're almost halfway there. So I suggest you all, when it comes to like solving these problems, is the first thing to make a good drawing and then label it. So here the question is, what's the pressure at point A? And we have these sort of parameters here, and we divided this U tube into 4 sections: A, B, C, and D. And what we're going to do is start from point D and work our way back to point A. So these questions look quite intimidating at first, but once you start to break it down, it will become a lot easier. So the reason why we're starting at point D is because we know that this system is open. So we know that at point D, the pressure is going to be atmospheric because this is an open tube. So the number one thing is pressure at point D equals to pressure at the atmosphere, so ATM. So this is so far, pretty clear. We're at here right now. Then we move down to C2 dash, and because what we see here is that there is water here, and then we know that the equation for static pressure is rho times G times H. Then we will know that PC2 dash equals PD plus rho water times G times 0.25, because that's the sort of height of the water there. Then, so we know what's the pressure here. Because these are at the same level, we'll know that, oh yeah, they are the same level and they are connected, so they will have the same pressure. So P, just one sec, P, C2 dash, C dash, yeah, P C dash will be equal to P C2 dash, because they're connected and they're at the same level. This is fairly intuitive. And then we move on to C. So if you look at the actual drawing, you see that that's liquid or like fluid that is filled on the C section is actually air, and air has a relatively insignificant density compared to mercury and water. So in this case, we are just going to ignore this difference. So what we're going to do is PC equals PC dash, which equals PC2 dash, which equals PD plus rho water G 0.25. So we're already made it this far. Now the difference between C and B dash is 30 centimeters of mercury. So what we're going to do is P B dash will equal PC plus this gauge pressure of 30 centimeters of mercury, which is going to be rho mercury times G times 0.3. Is this clear so far? Yeah? And then we move to PB, and since we know that these are connected and it's the same level, PB equals PB dash. But at the same time, we're at here, and now we can find an expression for the pressure at A. So we know that the pressure difference between point B and point A is 0.7 meters or 70 centimeters of water. Then we can write an expression for PA. So PA equals or yeah, PA. No, sorry. Let's write it a different way. PB equals PA. So the pressure here plus 70 centimeters of water. PA plus rho water G 0.7. Which actually, and then because we know what PB is, and we know what PA is, we can we can figure out what PA is. So we're just gonna put PB here, which will then which will then become PA. No, sorry, one sec. PB equals PA plus rho water G 0.25 plus rho mercury G 0.3. And then we sort of shuffle PA out from the equation, and then we get PA equals P plus oh, sorry, yeah, I think I got stuck. P is going to be PB equals PA plus, oh yeah, P, which equals, sorry, PB equals PA plus that. Plus wait, what's the difference between this PA and that PA?
That is atmospheric pressure. This is the PA.
Oh yeah. So here PB is atmospheric plus 1 mass equals 80 sorry. Atmospheric pressure plus equals PA. So PB equals P80 plus raw water G 0.25 plus raw mercury G 0.3 equals PA plus raw water G 0.7. So then P at point A is P80 plus raw water G 0.25 plus raw mercury G 0.3 minus raw mercury G 0.7. And then you know that an atmospheric pressure is 1,000 kilo, 1 bar. 1 bar. This is I'll just write it out. Oh no. Oh yeah, I mean. Okay, yeah. Okay. So I don't know, do I need to fully explain this? Do I need to plug it in? So yeah. And if you plug in all the variables, then you will get that PA will become PATM plus 35.5 kilonewton meter to the minus 2. Yeah. Okay, is that, did everybody have time to write this down? I'm just going to assume yes. And then for question 2, should we give them 5 minutes? Okay. Yeah, yeah. Don't worry about it. Honestly, I don't. So, I'm looking at question 5.
Sorry?
I'm looking at question 5 here.
Okay.
And I'm not sure.
You won't be able to make it.
Yeah.
I won't. Okay, let's see.
But no, we can just give. Once we're at 5, we can just give them time to have it a go, and then
Okay, we'll look
we
into
can
it.
look into it.
getting 25. They won't be getting times 5 and 6.
Yeah, probably. I mean, it's like
It's not that
if
tough,
they.
but
No, it's not tough.
I never studied,
Yeah. I mean, how was your experience when you were doing tutorials in your undergrad in year 1? Was it like this?
No, a year on I didn't do it. I mean, this is the first time I'm doing it.
No, as in, when you were studying.
I was
for
studying.
medical.
Yeah, it was back in India. The system is a bit different there.
No, but how was that like?
Yeah, it was okay.
But was it like this?
I mean, a bit different.
I feel like once they start talking, we can start doing this.
Okay.
Okay. Yeah, just
Where is the question? I want to see the question.
oh, the question.
Yeah.
I'll get it answer. There you go.
No, not this one, right?
No, the real. Oh,
This one, the one.
oh, the fifth one.
No, second one.
Second one. This one.
Okay.
So we'll go to the second question. Please listen. In the second question, density is not a constant. In the first question, density is not a constant. It's given as a function of y, and y starts from below the free surface. It's not from the bottom. It's below the free surface. I mean, y starts from here. Okay. So density is a function of y, and we have been asked to find out gauge pressure at the bottom of the tank. Okay, so based on the fundamental form of hydrostatic equation, we know that W by dou Z is minus rho g. Now you have been asked to find out the P at the bottom, so you need to integrate from the top to the bottom. I mean, from the y equal to 0 to y is equal to 1 meter. So if you integrate it, you will get the answer. It's a straightforward question. Dou P by dou y is equal to rho g. Del P is equal to integral 0 to L rho g dy. Then you integrate from 0 to 1, you will be getting, then you put the values, you will be getting the answer 10.5, 10.8 kilopascal. That's it.
Yeah, is that clear, or do you have any questions? I mean, I feel like, yeah, in this second question, the way that you would approach this is, first you obviously draw the tank, and then you realize where is y equals 0 and where y equals L. And yeah, just integrate the equation. Yeah, just give them some time to So yeah, and the reason why you integrate from 1 to 0 is because the top of the tank is at y equals 0, and the bottom of the tank is y equals L, which is 1 meter in our case. And yeah, I think yeah, he's skipping a few steps from here to there, but I mean,
those things I think they can do right.
yeah, okay, we're gonna move into question 3, if that's okay, or are you still writing it down? Okay. Question 3. Okay, let me see. Do you want me to do question 3? I think it would be good for them to like have a go through it really slowly.
Okay.
So yeah, so I'll just start writing up. Because I don't know, I'm a really visual learner.
Okay.
But let me just sit down. And I mean, if we run out of time, then I don't think it's that big of an issue. It's I don't know. I'd rather be slow and make 100%. So. I'm just looking at my awful illustration. So the first thing you should do, again, in this problem is to create a drawing. Mine is a bit, well, I think it's just, good for your illustration. So essentially we have two different states. The first state is when the sort of instrument is open to the air, and when it's open to the air, it's at level B. And the second state is when we close the system and apply the pressure. And once we apply the pressure, what we are going to see is this level of liquid will go up here. And that level of liquid in the tank will go down here. So the first thing we need to figure out is what is the pressure when the system is open to air. And so first point is pressure at B. So pressure at B is going to be PB equals rho GH, which is yes. So yeah, this H, this is the new level, the old level, and the pressure difference is going to be rho GH. Because this is sort of inclined, we can find the expression for H as rho G D times sinus alpha, because here you see triangle. This being alpha, this is H, and this is D. So you use this to get this. And then the second thing that you have to think about is pressure at point C, which is going to be here. So PC equals pressure at point B plus rho G delta H. And delta H this time is the displacement here once we apply the pressure. And this you can express it as rho G D sinus alpha plus rho G delta H. So here, the next step is realizing that in this question we treat oil as an incompressible fluid. So the displacement here will be equal to the displacement here. I mean, the same volume will be displaced. So the way you calculate this is that you have the two different surface areas and the two different displacements. So you can write an expression for that, which will be A, so the big surface, this one, times delta H, times delta H. So the displacement here will equal A times H, so the displacement here, because it's an incompressible fluid. That will give you delta H equals small a times capital over capital A times D. And once you have this equation and this equation, you can substitute these two together, and you will get PC equals rho G D sinus alpha plus A over big A. And if you substitute the numbers, you will know that A times big A equals 1 over 2 to the power second. There's something wrong. Oh, there's something wrong with this. Okay, so what should we do? The question.
This is answer sheet, right?
Oh, but if this is the surface area, so not the diameter. So find that's nice. A over A is going to be 1 pi squared. Yes, you're right. And then oh, so it's 0.0. Yeah? And from here, you will just have to rearrange this equation to sinus alpha, and then plug the numbers in, and then you will get that alpha is 2.85 degrees. Do we need to have in 1 over 4? I mean, this is no. I mean, so yeah. Yes. So do you want to give them some explanation for this?
I think they can do it, right?
Hmm?
I think they can do it, right?
No, I mean just explain what the idea.
It's a substitution for
Yeah. Yeah, so here what happens is he's substituting the surface and expresses it with diameters. Oh. Right. Yeah. Yeah. Yeah, I think there's this stuff in here. Okay, I think we can move on. And then question 4 will give you again. Yeah. I like your handwriting. I like your handwriting. Yeah. No, yeah, so we just because it's in liquid state. In liquid state, the atoms are packed together. That's what it assumes that they have to change volume. So normally all the liquids is assumed incompressible. In reality, there's going to be really, really significant, but really insignificant for gases. Because gases, the molecules are not so tiny, and with solids, solids have like this crystalline structure, there's no space. 2 minutes until. I'm so surprised that so many students come to this session at 5 o'clock in the afternoon at Friday. It's crazy.
First tutorial it was numbers a bit more.
You thought numbers would be there?
The first tutorial.
Oh no,
was-
yeah, first one is loads of students, yeah.
Yeah. Now it just came down actually.
Yeah. These systems of tutorials for engineering, I don't know how efficient they are. Because when I was first year, I would just skip these tutorials in the first 5 or 6 weeks, and then yeah, just do it. No, because
If you get these answer sheets, then that will do, right?
yeah, exactly, yeah.
Unless there is no attendance, there is no purpose of coming here actually.
Yeah, and it's like, I mean, I guess you can't do it otherwise for first year students, because for third years they are expected to come to you with a question, but with first years you kind of have to like go through the answers step by step. Have you considered a career in academia, becoming a professor? Really? Yeah, so this is the first steps.
Yeah. What about you?
I mean, I really like doing this, but at the same time I think it's like really difficult to do it good. And also industry just pays so well.
Yeah.
But we'll see. I'm open to the idea, and I like it. So yes.
So let's move on to question 4.